Okay, in this problem you have a 47 kilogram person. They're being descended, see a distance 2.8 and 2.5 seconds. They're starting from rest, so since they're starting from rest we can say VI is equal to 0. And then we can say that delta y, going back to our kinematic equation, is just going to equal to 1/2 times our acceleration times t squared. So since we're descending, we'll let this be negative 2.8 equal to 1/2 times my acceleration times 2.5 squared. Again, I'll make that into a better looking A. And what you want to do here is just solve for your acceleration. And when you solve for your acceleration, on this problem I believe you get negative 0.896. So you're going down, and that's going to be meters per second squared. Alright, from that, go ahead and draw yourself a free body diagram. We'll have the person's mass times gravity coming down. So that's going to be 47 times 90.8. That'll give us a value of about 460.6. We'll have the tension in the rope going up. So we'll call that F tension. Okay, and then we can just go back and say the summation of forces in the y direction is equal to mass times acceleration. We got the force T minus 460 is equal to the mass, the 47, and then we'll just multiply that by negative 0.896. Now at this point all you have to do is solve for acceleration, solve for Ft. F of t in this case will be about 418.5 roughly newtons. Alright, so that's how you get the tension. That one's pretty easy. Now to determine the mass, all we need to do here is draw a free body diagram of this object here. So I'll come down here, we'll draw a little dot. On this one you want to break it into components first, because if you think about it, what the free body diagram would look like right now would be something like this, but we know the acceleration is going to go back up this direction. So what we want to do is create a new axis system that's going to go like in this direction and in this direction here. So that's what I want to do here. So I'm going to break this one into its components. So let me get rid of this little line here. So to do that, its components are going to look like this. Oops, get a vector. Going to look like this and then back down like this. Now the angle, if this is 50 degrees, this angle here has got to also be 50 degrees here. And we could label this as mg. This one here would be mg times the cosine of 50. This would be mg times the sine of 50. Now we'll draw a free body diagram with this being our x-axis going this way, y-axis going this way. And when I do that, I'll have a force coming down like this, a force coming down like this. I'll have the normal force going back up, and I'll have a force going this way like that. I'm going to get everything lined up a little bit better. Make that a little bit longer. Alright. So we know this one is going to be mg times the cosine of 50. This would be our normal force over here, and our normal force in this case would also equal to mg cosine 50. This value here is coming down. This would be mg times the sine of 50. Now this is going to be our Ft. Now we know that Ft is equal to 418.5. Alright, so what we're doing is I'm creating an axis system, like I said, that's going back up, or going parallel to here, and we're letting that be the x direction, or the x-axis I should say. And anything that goes this way we're going to let it to be positive, and anything that goes down we're going to let it to be negative. So when I sum my forces in the x direction, here I'll get minus mg times the sine of 50 plus 418.5 is equal to the mass, which is m, and we're going to multiply that by the acceleration, and the acceleration is going to be 8.896. Again, I'm letting that be positive here because we've determined anything that goes this direction is going to be positive. Move this to the other side. So now we're going to get 418.5 is equal to m times 0.896 plus m times 9.8 times sine of 50. So when we run that number, let's rewrite that as 418.5 is equal to 0.896 mass plus 7.507 mass. Add these two together. Gives me a value of about 8.403 mass is equal to 418.5. So we solve for mass, and we'll get 418.5 divided by 8.403. And let's run that number, 418. But that gives us about 49.7 kilograms. Okay, and their answer they're given is about 49.8. So they're right there in the ballpark. So that's the answer on that one. Again, just good free body diagrams took you right to the answer.